Static routing is a form of routing that occurs when a router uses a manually configured routing entry, rather than information from a dynamic routing protocol to forward traffic. In many cases, static routes are usually manually configured by a network administrator by adding in entries into a routing table, though this may not always be the case. Unlike dynamic routing, static routes are fixed and do not change if the network has changed or reconfigured. Static routing and dynamic routing are not mutually exclusive. Both dynamic routing and static routing are usually used on a router to maximize routing efficiency and to provide backups in the event that dynamic routing information fails to be exchanged. Static routing can also be used in stub networks, or to provide a gateway of last resort. Uses: static routing may have the following uses. Static routing can be used to define an exit point from a router when no other routes are available or necessary. This is called a default route. Static routing can be used for small networks that require only one or two routes. This is often more efficient since a link is not being wasted by exchanging dynamic routing information. Static routing is often used as a complement to dynamic routing to provide a fail-safe backup in the event that a dynamic route is unavailable. Static routing is often used to help transfer routing information from one routing protocol to another. Disadvantages: static routing can have some potential disadvantages. Human error: in many cases, static routes are manually configured. This increases the potential for input mistakes. Administrators can make mistakes and mistype in network information, or configure incorrect routing paths by mistake. Fault tolerance: static routing is not fault-tolerant. This means that when there is a change in the network or a failure occurs between two statically defined devices, traffic will not be rerouted. As a result, the network is unusable until the failure is repaired or the static route is manually reconfigured by an administrator. Administrative distance: static routes typically take precedence over routes configured with a dynamic routing protocol. This means that static routes may prevent routing protocols from working as intended. A solution is to manually modify the administrative distance. Administrative overhead: static routes must be configured on each router in the network. This configuration can take a long time if there are many routers. It also means that reconfiguration can be slow and inefficient. Dynamic routing, on the other hand, automatically propagates routing changes, reducing the need for manual reconfiguration. Example: to route IP traffic destined for the network 10.10.20.0/24 via the next hop router with the IPv4 address of 192.168.100.1, the following configuration commands or steps can be used. Linux: in most Linux distributions, a static route can be added using the uproot2 command. The following is typed at a terminal. Cisco routers have the ability to have static routes added to their routing tables. On Cisco routers that use the Cisco IOS, rather than a graphical user interface, the static route can be added as follows. Router enable, router configure terminal, router, config, uproot 10.10.20.255.255.255.192.168.100.1. Cisco routers also provide the option of specifying the exiting interface, rather than the IP address of the next hop router. The following global configuration is an example of how to do this. Router, config, uproot 10.10.20.255.255.255.0 serial 00. Static routes may also be removed using the following global configuration command. Router, config, no uproot 10.10.20.255.255.255.0 In general, static routes added to the routing table will override routes delivered through a routing protocol, resulting in suboptimal performance. Therefore, it is advised to set the administrative distance on the route. Router, config, uproot 10.10.20.255.255.255.0 example route 1, admin distance. See also. References